Hello everyone. Welcome to our lesson entitled Longitude and Time. As you know, lines of latitude and lines of longitude are used to locate places around the world. Additionally, lines of longitude are also used to calculate time. Therefore, our lesson for today, calculating time along the longitudes. Before we begin, let us establish some basic facts about lines of longitude. Lines of longitude are also called as meridians or parallels of longitude, run from north to south pole. The main line of longitude, which is Greenwich prime meridian, divides the earth into eastern and western hemisphere. What you need to know before you start this topic. Important facts. The sun rises in the east and sets in the west. Therefore, people living in the east will be seeing the sun first. Every 15 degrees of longitude represents 1 hour. It means if you move from 0 degree towards the 15 degree east or western hemisphere, you will be losing and gaining 1 hour time. 1 degree of longitude is 4 minutes. It means 1 degree is representing 4 minutes. The prime or Greenwich meridian is always at 0 degree. So, Greenwich meridian time or Greenwich mean time is always at 0 degree. Now I am going to show you few worked examples on this topic. Local time. The local time of a place can be calculated if we know the longitude of the place. So if you know the longitude of any place, you can calculate the local time. We can understand this concept by the following examples to find the local time when we know the longitude. So before we start this example, I will show you few basic facts. The first concept for this topic is, this is our 0 degree GMT or Greenwich Mean Time. If you move from 0 degree towards the east, you will be gaining your time. If you move from 0 degree towards the west, you will be losing your time. Concept number 1. Concept number 2, what I have already discussed, which is 1 degree longitude is representing 4 minutes. So if you move from 0 degree towards the east or west 1 degree, you will be gaining or losing 4 minutes time. So basically 1 degree is representing 4 minutes and 15 degree will be representing 1 hour or 60 minutes. So this is the main fact, basic fact, what you need to know before you start this example. So example number 1, if the GMT at 0 degree longitude is 12 noon, find the local time at station A and B. So the GMT line, which is at 0 degree, the time is given 12 noon for this. To find the local time at station A and B. So station A, this is our station A and this line is our station B. So we need to see whether the station A is situated towards the eastern side or western side. The same for station B also. So let me read the data. The difference in longitude between 0 degree and station A is 60 degree towards the east. Okay, so I have already got the longitude number also. So I can write 60 degree east. So station A is at eastern side, okay, and the longitude is 60 degree. And station B, the difference in longitude between 0 and station B is 30 degree towards the west. So I can write 30 degree west. Okay, so the data is very clear. It means if you move from 0 degree towards the eastern side, you will be gaining your time. If you move from 0 degree towards the western side, you will be losing your time. So before 0 degree, before 12 noon, it will be your AM. The time will come in AM. And the same way, if you move from 0 degree towards the east, your time will be in PM. So that's the logic. At station A, the difference in longitude between 0 degree and station A is 60 degree towards the east. I have already written it. Since it is 12 o'clock at 0 degree, the difference of time between A and 0 will be 60 into 4. Okay, so why it is 60 into 4? Because 1 degree is representing 4 minutes. You have to cover till 60 degree. So to get the exact time, you have to do the calculation in such way, 60 into 4. So if you do this calculation, you will get 240 minutes, okay, or I can say 4 hours. The same way, this is one way to do this calculation. Another way, if you want to do the calculation directly, so you can directly write 60 divided by 15, as I have already done here, 60 divided by 15. So you will get the direct number 4 hours. Okay, so this is different way, another way to do the same calculation. So I am getting the time difference, which is 4 hours. So I can say that if it is 12 noon at 0 degree, then it will be that station A, which is 4 hours ahead of Greenwich Mean Time. This is a GMT line, right? So I have to add the time. So 12 plus 4. If you do this, then definitely my time will be 16 hours. Or I can say that therefore the time at station A will be 4 PM. Okay, so I can write the exact time over here. So the time is 4 PM at station A. Now we'll do the same calculation for station B. Okay, so let me do the same calculation for station B. 30 degree west. Okay, I am using some different color. So the difference of time between B and 0 will be 30 into 4. The same way how we have done the calculation for station A, the same way we'll do the calculation for station B. So directly we can do 30 into 4. So you will be getting 120 minutes, or if you convert this 120 minutes to hours, you will get 2 hours. The same way, if you want to do the direct calculation, then definitely what you have to do, 30 divided by 15, then directly you will get this number, 2 hours. Okay, so since B is situated to the west of prime meridian, you are losing your time, so you have to do the subtract for this. So the local time at B will be 12 minus 2. So how much you will get? 10 AM. Why? Because I have already told you before 0 degree, as you are losing your time, so it will be your AM. Okay, so that is why I have written 10 a.m. So this is the calculation. This is how you could do the calculation if the longitude is already given for a place. So this is logic number 1. I'll show you more examples to understand this concept more clearly. Places ahead of Greenwich. What is the time in country A located on 45 degree east if the time at Greenwich is 12 noon? So 45 degree east means the time will come in PM. So step number 1, calculate the time difference. So the longitude is 45, so 45 divided by 15. As I already told you, this is how you can do the direct calculation. So 45 divided by 15, the time will be 3 hours. Step number 2, calculate the actual time. So you have to add 3 hours to 12 noon. So the time at country A will be 3 hours ahead of Greenwich, or 3 PM. So this is a graphical representation of this calculation what I showed you. Okay. Places ahead of Greenwich. One more calculation. What is the time in country B located on 70 degree east if the time is at Greenwich is 12 noon? Step number 1, calculate the time difference. 76 divided by 15. So the number will come 5 hours with 1 degree remaining. So for 1 degree, as I already told you, 1 degree represents 4 minutes. So step 2, calculate the actual time. You have to add 5 hours 4 minutes to 12 noon. So the time at country B will be 5 hours and 4 minutes ahead of Greenwich, or 5:04 PM. I have done this calculation in a notebook. So what is the time in country B located on 76 degree east if the time at Greenwich is 12 noon? The same calculation, if examiner asks you the same question during exam, you can represent your answer in such way how I have done here. So the question will come for 2 marks and sometime for 3 marks, but basically if you are studying in 9th standard, the question will come for 2 marks. It is 12 o'clock at 0 degree. The difference of time between Greenwich 0 degree and B will be 5 hours 4 minutes. 4 minutes. So 76 divided by 15, 5 hours with 1 degree remaining. 1 degree equals to 4 minutes. Okay. I have done the calculation separately also for our understanding. As country B is located to the east, so it will be farther ahead of time. So it will be 5 hours 4 minutes ahead of Greenwich time. The time at country B will be 5:04 PM. So basically we are adding 5 hours 4 minutes, okay, to 12 noon. This is the graphical representation for this calculation. Just have a look. One more. This calculation is something different, though we have done this calculation in the beginning when I showed you the example. What is the time in country C located on 60 degree west? 60 degree west means the answer will come in AM. If the time at Greenwich 12 noon. Step number 1, calculate the time difference. 60 divided by 15. The time difference is 4 hours. So step number 2, calculate the actual time. You have to subtract 4 hours from 12 noon. The time at country C will be 4 hours behind the time at Greenwich, or the time will be 8 AM. Okay. So if it is 12 noon at 0 degree, the time will be at 60 degree west is 8 AM. after doing this calculation. Basically the time is behind because the longitude which is located towards the western hemisphere. Let me show you the graphical representation for the same. So 60 degree west, C. So this is a graphical representation for country C, 60 degree west. Places behind Greenwich. What is the time in country D located on 76 degree west if the time at Greenwich is 12 noon? So after seeing this longitudinal number, we can say that the answer will come in AM. Step number 1, calculate the time difference, 76. So according to this data, the longitudinal number is already given, which is 76. So as I already told you, we can do the direct calculation. So 76 divided by 15, the answer will come 5 hours with 1 degree remaining. 1 degree is representing 4 minutes. So step 2, calculate the actual time. So you have to do the subtract. So subtract 5 hours and 4 minutes from 12 noon. The time at country D will be 5 hours and 4 minutes behind the time at Greenwich, or 6:56 AM. So let me show you the graphical representation for the same 76 degree west. So this is the location for country D, 76 degree west. Places in the same hemisphere farther east. This is something different than the previous calculations. So the data is about the places which are located at the same hemisphere. So if it is 3 p.m. at 45 degree east, suppose this is our 45 degree east, what time will it be at 75 degree east? So 75 degree east, we have to find the time for 75 degree east, and this is a 0 degree GMT line. So step number 1, firstly what you have to do, because the question is given for the same hemisphere farther east, towards the east, calculate the difference in degrees. So firstly you have to get the longitudinal difference. Okay, so 75 minus 45, the answer will come 30 degree. Okay, so I have written a small note here, 75 degree east is 30 degree to the east of 45 degree east. Step number 2, calculate the difference in time. So you have already got the number 30 degree, right? So the same way you have to do the calculation, 30 divided by 15, so the time difference is 2 hours. Step number 3, calculate the actual time. The time at 75 will be 2 hours ahead of that at 45 degree. So the time which is already given for 45 degree east, that is 3 p.m. right? So you have to add 2 hours with 3 p.m. So 3 plus 2, your time will come 5 p.m. for 75 degree east, 5 p.m. So this is the answer. Places in the same hemisphere farther west. So this calculation is about western hemisphere or farther west. Let me read the question. If it is 5 a.m. at 35 degree west, what time will it be at 90 degree west? I have already represented the same in graphical manner. So 35 degree west, the time is already given 5 a.m. What will be the time at 90 degree west? So this is my question. I have drawn one more line over here, which is 0 degree GMT line, that is for our understanding. Step number 1, So to do this calculation, what you have to do first, calculate the difference in degrees. Calculate the differences degrees in degrees means you have to calculate the difference which is longitudinal difference. So 90 minus 35, the answer is 55 degree. So the longitudinal difference in degrees is 55 degree. Note, 90 degree west is 55 degree to the west of 35 degree west. Step 2. Calculate the difference in time. 55 degree divided by 15 degree. The answer is 3 hours with 10 degree remaining. As we all know, 1 degree represents 4 minutes. So 10 degree will be representing 40 minutes. Difference in time, therefore 3 hours and 40 minutes. Step 3 or the final step. Calculate the actual time. So 5 a.m. we already know this number after seeing this question. So 5 a.m. minus 3 hours and 40 minutes equals to 1:20 a.m. So this is my final answer for 90 degree west. Note that we subtract as time at 90 degree west is behind, that is 35 degree west. So I can write 1:20 a.m. at 90 degree west. So places across the hemisphere, it means if you see that both the longitudinal numbers are given by using both the hemisphere, then what you have to do in that case. So this calculation is about that. If it is 6 p.m. at 45 degree east, what time will it be at 60 degree west? So this question is about both the hemisphere, east and west. So step number 1, calculate the time difference in degrees. So as I told you that this is something different, so what you have to do, as both the longitudinal extensions are situated for both the hemispheres, it means for eastern and western hemisphere, so to get the time longitudinal difference, you have to do the plus. Okay, you have to add the longitudinal difference. So 45 plus 60, so total difference in degrees is 105. Note that we add degree for place in different hemispheres. So this is very important for this kind of calculation. Please do remember, don't forget it. Step 2, calculate the difference in time. 105 degree divided by 15, 7 hours. So the final step, step number 3, calculate the actual time at 60 degree west, 6 p.m. minus 7 hour. My answer is 11 a.m. Note that we subtract as the time as 60 degree west is behind, that is at 45 degree west. So this is how we have to do the calculation for the places if the question is given for both the hemisphere. I hope you all understood. If you have any doubt or any query related to the same topic, please let me know and write the same in the comment section. Thank you so much.